Hello, everyone. Thank you for joining this webinar, AI-assisted network monitoring, real or hype, in collaboration between Capacity Media and Kentik. My name is Jack Allen. I'm a reporter with Capacity Media, and I'll be hosting the webinar. And I'd like to introduce Chris O'Brien, Senior Principal Product Manager at Kentik, and Chris's colleague, Nina Bargisen, who's Director, Technical Evangelism at Kentik.
Hello.
Chris, Nina, thanks so much for joining us. So during the webinar, Chris and Nina are going to discuss how lean teams tackle the chaos of network monitoring while keeping costs low and ensuring high quality digital experiences. Can AI meaningfully contribute to this challenge, or is it just hype? During the webinar, you will be able to learn how AI and machine learning have been used in network observability historically, how to use large language models to accelerate troubleshooting today, and then we'll move on to how to collect and analyze data from diverse sources, what Kentik's newly launched software as a service NMS adds to the picture, and the benefits of streaming telemetry with a live demonstration. We'll then have a 15-minute Q&A at the end, so please send your questions throughout the webinar using the text box below the video, and all of the questions that you ask today will be anonymous. In the unlikely event that you experience any technical difficulties, please just refresh your window and this should fix it. So yeah, that's kind of all of the housekeeping for me, so I will hand over to Chris and Nina.
Thank you, Jack. So Chris, I've been wondering, because we were exactly discussing, is this really hype? Because I'm getting all of these emails into my email box these days about AI ops and AI this and AI that, and AI now it apparently is called AI ops, like DevOps was yesterday, but now it's AI ops. And what the fuck's going on, Chris? Do you know this? I'm really confused because I'm mostly using AI to sort of help me write.
Yeah. I mean, there has been a lot of quick progress on the large language model with stuff like ChatGPT, and I think that's drawing more attention to this. You know, we've been trying to apply, I mean, the industry largely of network observability have been trying to apply AI and ML technologies to the network observability space for at least 15 years, maybe longer, and certainly a lot of the fundamentals in machine learning have been around for several decades. So, you know, there's a big shift in attention though right now. And so if we think about like what's actually true, it also seems like every company in the world is talking about their new AI thing because everyone's experimenting in this space and trying to build something useful for folks. You know, if we I've been working on building network monitoring systems and other network observability tools for about a decade. And I remember early on, we've sort of a couple of iterations of how we've applied AI and ML to the space that I've seen anyway. The first one, maybe the most boring one, but also probably the most useful one, is calculating baselines. So this is like, you know, the challenge that folks have is they have all of these different finite resources, RAM, CPU, interface utilization, and they have thousands, tens of thousands, hundreds of thousands of these finite resources. And they want to get an alert if there's a problem, they're running out of a resource. Well, all of those resources are behaving differently, right? And so some you may set a threshold of 90%, but you know, memory goes over 90% and it's fine. Some may run at 50% normally, and if it goes to 75%, that's an alert-worthy event. And so, you know, what automatic baselines do for you is rather than trying to manually set thousands, tens of thousands, hundreds of thousands of thresholds, which simply wouldn't work, you can use machine learning to calculate what is normal for that value. And normal can include both, you know, what is normal on average for all of time, but more likely will include normal for this time of day, 8 a.m. as compared to 5 p.m. as compared to midnight, or this time of week on a Monday versus a Sunday, or this time of year even, some of these models will look at. And that uses a machine learning algorithm called linear regression, which may be one of the most boring ones, but
I know that one. We used
yeah,
that years ago when I was working in a network planning department, and we were just looking at the peaks of traffic, and we would estimate growth. And then we would use that growth to sort of predict when did we need to build for the next year, and plan the budget from that. That was sort of straightforward. We did not think of that as AI.
Yeah. So there's thresholding. There's also sort of capacity runout that linear regression is often used for, and it is technically machine learning, but it is so boring and so often used, we don't really think about it as such. But it is the most successful application of machine learning to date, at least in long term. The other one that folks have been playing with and sort of getting really excited about is machine learning for like alert aggregation and suppression. Everyone has this problem of too many alerts. What's actionable? When 100 alerts go off at the same time, which ones do I need to look at, or which ones are sort of closest to the root of the problem that I need to troubleshoot? And a number of companies have worked on that. I think Moogsoft most famously worked on that, accepting data from all sorts of different monitoring and observability platforms, and then comparing that data and trying to come to conclusions about how to fit the alerts together. I think that holds a lot of promise, and I think some folks were successful with Moogsoft, but man, that's a tough deal, right? Because if you miss one critical alarm, you're in trouble.
Yeah, no, I know. And I think I heard about this because, and what I heard about this is that it's actually really, really hard problem, and you need so much data so that your models can learn what is important and not. That up to now, I thought it was only the hyperscalers who actually had enough data that they could train their models to be useful. So is that rightly perceived, do you think?
Yeah, I mean, I think that's more right than wrong. It's not like no one is doing that specific use case, but I think particularly as we get into folks will try and extend that use case. If I can see all my alarms and I can see all my data, and I can start to pick out which alarm is closest to the root of the problem, can I do root cause analysis? Like root cause analysis is almost like the holy grail of network observability. Everyone dreams of it. No one has it. And as far as I've seen, no one is even close. And, it's funny because maybe 3-4 years ago, as AI and ML was first starting to sort of take the industry by storm in terms of messaging and hype, if not actual practical value, I was working on building NMS, and I was constantly being asked by my boss what we're doing about this, the marketing department what we're doing about this, analysts. Every analyst I spoke to asked, what are you doing for AI and ML? And we had some brilliant architects on it, and we would brainstorm and try different things. But at the end of the day, we were trying to make something valuable, and we hadn't found the use case for that yet. And so, after, interestingly, the folks that were asking me the least about it were customers. But maybe after the 5th or the 6th analyst asked me about, I was in person with this gentleman, and we had a good relationship with him. And I was like, okay, so, we're trying, he asked me the question again. And I said, we're trying to create something actually valuable here. And so we've got some effort. We're looking, we're discovering, we're prototyping, but we're not really finding something great. And we're not going to release something and talk about something unless we have something of practical value. And I went a step further because I was getting frustrated. I was like, in fact, I have never seen a single instance of someone getting real value out of AI and ML for network observability in production. Have you? And I was flabbergasted that he said no. So this is a guy whose full-time job is to go and talk to vendors, go and talk to customers, go and talk to other analysts, talk to all of these people to understand the industry. He's talking nearly nonstop about AI and ML and has never spoken to someone who is getting practical value in production. So I think that really speaks to the degree of hype that was there 4 years ago, and part of what's going on now again with, coming back into focus with all the improvements with and breakthroughs with ChatGPT and other LLMs.
Yeah. So how is it different today? I mean, why is the hype starting? Because there must be some value now, right? Well,
yeah. Well, when the industry was working on it before, we didn't have ChatGPT and LLMs like it. I mean, there has been an incredible advancement there, and so the question is, does this become a new tool that could solve problems we weren't able to solve before?
But how is that? Because I mean, LLM, it's sort of like you look at a lot of text and then you can guess what comes up next, and then you create text that way. That's how it works right now. I mean, how does it work in the context of network observability? I'm not quite getting that.
Yeah, I mean, there's a couple of companies trying different approaches. I think a lot of LLM does content generation, as we've seen. Fundamentally, LLMs are about understanding language input, whether that is text or speech, and then output in the form of text. I guess or again, speech. So we've been working at Kentik with LLMs for a little while now, and have come up with some pretty interesting uses. So I'll share my screen. We can take a look at something real here.
Oh yeah.
Okay, so we have this feature called Query Assistant, and what this allows you to do is, all the data we have about all the sort of NMS data that we have about your network, you can write a question here with natural language and start to inspect that data. So, for example, I could say interfaces with highest bandwidth. And in the background, the large language model is translating that into the proper query form. You see, we have this query builder on the right-hand side. You've always had access to this as a user, but there's a lot of fields here, and there's a lot of sort of ability to build complex, even regex filters on all sorts of different things here. And, everyone's collecting quite a bit of data nowadays. So you have all of these different categories. Then within each category, you have all sorts of different metrics. So to be able to just jump into a query, what the large language model is doing precisely is it's translating this sort of natural text, how I would type a question, into that query that is the correct format for Kentik NMS.
Right. So you don't have to sit and sift through all of the choices that you might have. And you have, like, I see hundreds of choices here. Yeah.
Yeah.
Exactly. So
we asked interfaces with highest bandwidth. This is actually, it's showing me max, which I don't like. I would use average. So I'll go to average here.
Oh, you would use average, right? Yeah. So being an old planner, I would use the 95 percentile, because, you can't really build to 40. If you do, I mean, you can, but depends on what kind of quality you want to deliver for your customers.
Yeah. That's fair. I guess I'm more of an enterprise engineer. So P95, I've always heard P95 is really popular with service providers. So I can just switch out to P95.
It's the holy grail. It's the holy grail.
The other thing I'm noticing is this is bit rate. If we're worried about sort of run out or something like that, we would want to be looking at utilization.
Yeah, there's a lot of correlation you have to do in your head there to figure out whether you're in danger or not.
Yeah, that's right. Okay. It looks like we got a couple interfaces who are reporting in the wrong capacity. We'll have to adjust those. But you can see we've pulled up the P95% in and out utilization. These are the top utilization across this test network that we have. And all of that's, we got the device and the interface name. So now I don't actually know what all of these, well, I know what this one is, but I don't know what all of these interfaces are for. I need descriptions for that. So maybe I want to add here, include interface descriptions. So really easy way to sort of interact with your network, and it's been fun for us to observe how users are using this. If I would imagine most of our audience has tried ChatGPT at some time, and so knows that pretty quickly you start get into this back and forth and start thinking about things a little bit differently, and maybe ask questions that you wouldn't normally ask your NMS. Maybe you wouldn't even normally ask your peer. And we've seen similar things as we're observing people using it. It's a super interesting way to have like a more natural interaction with your network data.
That's really cool. Yeah. So what is the data that we're looking at right now? Because Kentik's been mostly flow, but this is different. This is our NMS. And how does this come about? I mean, what would be done getting to the point where we can do this?
Yeah. So there's a couple of things going on. This data set is part of our new network monitoring system tool. It's NMS. So we launched that at the end of January, and so have a whole bunch of additional data, traditional NMS type data that we can now correlate with our flow data and do these sort of fine-grained explorative queries using the query builder or this query assistant over that same data, which is really why we got into it. Folks, our users of our flow data wanted to have that same sort of exploratory capability with their NMS data and be able to correlate those two things. So that's what we've tried to do here with NMS. And I think one of the fundamentals is how we're handling it on the data side, and that's a big part of how it makes it possible to do this sort of LLM stuff, much less, do the query builder, much less the LLM. So maybe we can take a look at that architecture. I think that helps explain it for sure. Pull back a couple of slides here. So basically how NMS works is you deploy a small software agent that does the data collection. We call that thing Ranger. Ranger talks with Kentik SaaS to understand what devices it needs to go and collect data from. And then we have this thing called a collection profile. This is just a little plain text file where you control and configure how data is, what protocol is used for data collection, how that data is collected, and importantly, how that data is normalized. And you can do that across a variety of different protocols. We currently have SNMP and streaming telemetry, which is super cool, working. And then we've really designed it to be kind of protocol agnostic, and we'd be working on API next here. But using those collection protocol profiles, you can normalize this traffic. So, as you send it up to Kentik ingest, and we use a pretty common influx line protocol here, as you send it up to Kentik ingest, then it's normalized into an open config inspired data model. Okay. And you can do that, of course, with multiple collectors. And since we're using influx line protocol, you can actually accept data from GNMIC, Telegraph, these other collectors that are really powerful collectors. And if you've got good data coming in through them, you may as well use that as well. I'm just noticing some little disconnected lines and some other oddities in the presentation software. But in any case, so as that data is put in Kentik ingest, it's stored in that normalized model. And that model is really what you saw on the right-hand side when I was looking up measurements and looking up metrics. So at that point, it doesn't matter whether the data came from SNMP or streaming telemetry or one of these collectors over here or anywhere else, really. All of that data is fed into Metrics Explorer, where you do your query. It's fed into your dashboards. It's fed into your alerts. So having to do that, yeah, go ahead.
So you're actually saying that we are ingesting data, we're combining data from different tools like SNMP and streaming telemetry? Because I whenever I talk to people about this, they've always gone, but we can't do streaming telemetry because we have like only 5 devices who are able to do it. So it's not really worth it, and we have to look in different tools. So do we fix that somehow?
Yeah, I mean, streaming telemetry is a really interesting one because there's so much sort of promise from the protocol, and there's so much excitement in small niche groups, but most devices don't support it. That's the practical reality, is most of our devices don't support it. And as we're slowly upgrading our network, maybe 5% of our devices support it. And really, I think because of where streaming telemetry came from, these really large hyperscalers that are telling the network vendors, hey, SNMP is not going to cut it for the granularity. It's not going to cut it for the accuracy that we want. And so you must support streaming telemetry, and maybe providing some strong recommendations as to how to support it. All of that ended up having streaming telemetry really designed and built for a hyperscaler environment where, you could contemplate, really the idea was to do a hard cutover from SNMP to streaming telemetry. But that doesn't, the number of service providers or even enterprises that works for, where their gear supports it and they could literally turn off SNMP. I mean, it's fast approaching zero. This is almost no one that can do that. So, I think what's left to be done with streaming telemetry is to make it approachable by normal networks. That is to say, not just the top 5 largest networks in the whole world.
Yeah. And remind me again, please, what is the strength of streaming telemetry? Because, we lived with SNMP for so many years. So, why is it worth it?
Yeah, you hear this SNMP is dead phrase, which I love, because it's it speaks to the aspiration that we all know of the challenges with SNMP, but
it's like IPv4 is dead. Oh, we know.
Yeah, but we're all running more SNMP than streaming telemetry by 50-fold. So it's very aspirational. There's a number of improvements with streaming telemetry. The first of which is fundamentally SNMP is a pole architecture. So the SNMP speaker will, or management system will send a request, an SNMP get, and request a piece of data. So say, hey, I have a question, piece of network infrastructure. Hey, Mr. Router, what's your interface bit counter out on this interface, right? And the router will receive that, realize it needs to prepare a response, and prepare that response and send that over. And so it's interesting, SNMP was invented in 1988. Nowadays, we're all using SNMP in basically the same way, which is we do that once every 5 minutes or 1 minute or 10 minutes, and we draw a graph with it, right? Because we need the graphs. That's Cacti, MRTG, RRD tool. There's some long-standing tools. Yeah. So if you think about, if that's the goal, is to have this data constantly flowing, it makes zero sense to do that all interrupt driven, ask the router that question over and over and over again every minute until the end of time. And so how streaming telemetry changes that is, streaming telemetry, the management system subscribes. It says, hey, I want this data, this sort of data, just send that to me as you have it. And that does 2 things. It's lower overhead because you're not constantly sending the same question over and over. The question is understood by the router, and the router also can schedule their own data sending, right? So it knows that this request is coming up, can fit it in its work along with all the other stuff it's doing. Router's main job is not to talk to the monitoring or management system, it's to send traffic, right? So we've always struggled with, they don't have the largest CPUs, and monitoring is not their priority. So anything we can do to make that overhead lower is better. So with streaming telemetry, you subscribe. And then the router sends those data points at whatever interval that you've subscribed at until the end of time or until a stop date, whatever you specify. This makes it way more efficient for streaming telemetry than SNMP. And the net result of that is, you see a lot of people running SNMP at like 5 minutes or sometimes 1 minute, sometimes 10-minute polling intervals. 10 minutes is a long time. And streaming telemetry, because it's so much more efficient, we can collect that data much more frequently without overloading the device. Okay, so it's collecting down at 1 minute, even for your largest chassis, makes sense. Collecting at 30 seconds or 10 seconds for a lot of data makes sense. For specialty data, like you're like, hey, this metric, I want to know right away when we pass some sort of threshold. You can collect every 2 seconds. You can collect at sub-second. So the granularity is a whole different thing.
That's a lot of data to ingest. Is that even possible with the limitations on space and databases that we have?
Yeah, I think we've gotten a lot better, especially as we move this stuff to the cloud. That's the approach we've taken. Certainly on the Kentik side, is that this ingests. In a lot of ways, streaming telemetry is similar to flow data. It's just being applied to metrics and these data sources that would traditionally be SNMP. So we've been collecting flow data for a long time at Kentik. Flow data streams in, right? We get it second by second, and it is typically a large amount of data, especially when you consider, it's SaaS. So we collect all of our customers' flow at the same time. And so that's how we've been able to make sure that scale, we have that sort of scale support with this streaming telemetry for NMS.
Okay, cool.
I did want to give a bit of a demonstration of streaming telemetry, maybe talk about one other benefit, but what we're talking about, sort of like that more frequent data collection, there's two things from that. One is, when you're analyzing a graph in history, right, you have much better granularity, and that's a big deal. The other thing is, when you're fighting a problem in real time, you can always go to the device and ask the device what's happening. But a lot of folks look at monitoring as, it goes red in monitoring and it goes green in monitoring. Monitoring is the authority on whether my network is okay or not. So folks will make a change to attempt to solve a problem and watch it really closely to see when monitoring goes green. That phrase, goes green, right? And that gives me a calming feeling in my chest from all my time troubleshooting outages. You want monitoring to go green, right?
Oh, but, yeah. I remember doing maintenance, and we would just sit there and wait for the MTRG graphs to get updated. It's sort of like, this thing I just did it work? Did it not work? Did it not work?
Yeah. I mean, the most common polling interval, I did some research about this recently. The most common polling interval people are using for the NMS is still 5 minutes, which is pretty slow. 5 minutes means, you will often have to wait between 5 or 10 minutes, 1 or 2 polling cycles, to get an answer you can be confident about. And 5 to 10 minutes is like an eternity in an outage. We can take a look at what it looks like with streaming telemetry here. So we've gone to this device. This is in our lab. This is running streaming telemetry, as you see there. And we've got this chart showing the history. We see this CPU went up. I've sort of created this problem of high CPU on this device around 6:30, 6:40. And then on the right-hand side, we have our high granularity view. And so this data is every 2 seconds. And this data is coming in live. So, right, 7:30:03, 7:30:05, and we're just pulling in new data points here. So imagine that I'm working an outage. I've said, hey, I've seen this huge uptick in CPU. In fact, this may be a 2-core box where one of the cores is completely utilized, and that's not good. So I've come up with a hypothesis, jumped on the device, figure out what processes are using CPU, and come up with a hypothesis about why that CPU is high. And so I'm going to implement a potential fix and then try and figure out if that worked or not. So I'll go in my terminal window over here and implement that fix now. And we'll see how long it takes for that data to make it all the way to the browser. I already see a decline here, down to 39%, down to 2%. So my fix did work, right? And so, man, something that would have taken 5 or 10 minutes, I really used to feel NMS would be like 5 or 10 minutes delayed. Like there's quite a gap between my NMS and my network infrastructure, but this, with streaming telemetry, it can feel much more directly connected, your NMS.
Yeah, that's pretty cool. Yeah, I like that. And this is all from our NMS tool.
Yeah, that's right. So because we've implemented that architecture, we've normalized all of the data, we now have it available in Metrics Explorer, which is our, the query builder you saw earlier, where you can build your own query about all of that data. And all of the data, then becomes accessible for the query assistant, and it doesn't matter whether it's coming in from streaming telemetry or SNMP. These are the things that we're trying to push network monitoring, network observability forward, and trying to think about, like, I think in 2024, waiting 5 or 10 minutes to understand for your network monitoring system to catch up with your infrastructure is crazy. Like, that's an unacceptable outage. So we need to figure out how to do better. And these are some of the tools we're using at Kentik to try and do that. Yeah.
I know that we are working as well on flow and making it easier for us to ask questions about the network traffic, combining it maybe as well with data from NMS. So we want to combine every kind of data we have. So I would like to show you what we've been working on that one. Is something we call, and I have to do a screen share first.
Yeah.
I can show it to you all I want on my own screen here, but that's not going to be helpful for anybody. So let me just share my screen, and here we just jumped into the Kentik tool. And we have a preview in the tool for some selected customers these days for something that we call Journeys. And here we've done the same thing that we've done in the Metrics Explorer, but we can hit any of the data sources that we have in the tool with this. So I'm going to create a new journey here. You have to do that. There you go.
I know in the query assistant side, we have to apply that to each one of our sort of query engines, because each query form is different. The way you query metric data is a little bit different from the way you query flow data. Like with flow, directionality is an essential part of like every query that you run, whereas with NMS data, directionality is a much less common and important attribute of that. So, I know we've been playing around with applying Query Assistant to Data Explorer and other query engines, but really interesting would be to compare all of these data sets together, right?
It is. So now I'm going to show you how the journeys work as well, because journeys is not just like Query Assistant. You have to go in and then you have to redo the thing. One thing that I really like about this is, like, say I pretend that I'm coming into work in the morning. I want to see what's going on in my network. So I started like, what are the top source ASNs that were sending traffic? And then, I remember, wait, I only want to look at what's going over my external network boundary. So I'm just going to add that part to the query. In the same way that, I've been playing with ChatGPT.
I do notice that with Query Assistant, I was having to like append, because in Query Assistant, we're just taking whatever query you just typed out and that's what we run. But it looks like this has some sense of history of the conversation, huh?
Yeah, it remembers the results and then it adds the next query to that one. If you use keywords like add or remove, or, you want to make sure that it understands you're talking about what you did before. So here now I have my external, but still I see a lot of traffic coming in, but I don't know enough yet. So I want to know, where does it come in, and what kind of interfaces did it come in on? TV, I need to spell here. TVT type, and who was sending it to me, like who is the next top neighbor. I can add all of this information to the query, and so you see, first of all, now it's the language model is thinking about, what does this even mean, and now it knows what it means, and now it's pulling out the data for me, and you can see I added the dimensions that I wanted to look at. And we have the original query is currently here. Oh, and now that's not a very good visual, right? So we don't want to. Let's have a visual that we can get some information out of. I love Sankey diagrams. How about you?
Yeah. Anything where you have a source and destination, Sankey are great, right?
Yeah. So it comes up here, because I mean, it comes out in the table, and I could do things about that one, but doesn't really.
I see there's also View and Data Explorer, so you could carry this back into the full sort of manual query builder if you want. Is that right?
That's right. You could jump back into the usual tool that we have. And I did that actually yesterday when I was preparing for this, and I got really frustrated because I had already gotten used to using natural language, and now I had to sit and work in the usual query tool. And why is it taking so long? I'm sorry.
I'm not seeing that last query come through. Yeah.
No.
And you mentioned that it's like translates the show as Sankey to a query, and then it runs the query, but it looks like where it's getting stuck is translating it with large language model into the query, huh?
Yeah, it really does. That's a little bit annoying, because that was not supposed to happen. Yeah.
I mean, that's been my experience with...
What, sorry?
That's been my experience with ChatGPT. It's like it can do so many amazing things, but it definitely stumbles at times, for sure. And it's hard for me to predict when it will stumble too.
Yeah, no, I agree. But it looks like now it finally understood what we wanted, and
it's running the query now.
Now it's running the query. So now I already know that exactly. We have a beautiful Sankey here, and now we notice, I really don't want to look at all of that customer traffic, because I'm happy about that. They pay me. I'm happy. So I'm just going to remove all of that traffic connectivity type customer. I know that it does take, that's interesting. We'll see if it understands. I have a typo here.
Yeah, it'll be interesting to see what it does with this, right? Because it translated into some query.
It did understand that, I must have meant source connectivity type.
Yeah.
So, because we have a little ability here to see what filters are actually added to the traffic, to the query. So I end up now I have a great overview of my external boundary traffic. And I notice, I have Google here. I know that I just negotiated that last year, that I would have a direct peering with Google. So why is the traffic not flowing on that one? Why does that not show up on my diagram? And I can't really remember Google's ASN right now, so I'm going to take a chance here.
Show session state for neighbor with peer AS Google ASN.
Yeah, and the ASN is 169. I knew that, and the session is down. So here's the reason why the traffic was not running.
Session state active, yeah.
Yeah. So, and notice here, we jumped right over to the metric explorer and we were looking into the NMS tool instead of looking at the flow data.
Yeah, that protocols, I was curious here as you were in that protocols BGP neighbors data is definitely a metrics explorer data location. Oh, and view in metrics explorer, there it is, yeah. Yeah, so how did it do all that? How did it translate it Google ASN into peer ASN 15169? It also found, I guess, the device that neighborship was on, PE31, and then it knew, I guess session states is just active, yeah?
Yeah. So, and this is, here we've been training the language model on examples, actually. Examples that, the team has been putting into the tool, and the tool is in its works right now. I wouldn't say that it's perfect yet, because it needs a lot of training. But imagine we will have all the training that we will get from ourselves and our customers over time, can refine this into a tool that eventually will be super helpful for doing analysis. And then, the final thing, if I like this, I can save it, and then, we can look at it some other day.
Just run those queries again on another day. That's interesting. Yeah. I mean, I think there is something here when it comes to applying LLMs to network observability. There's one thing that is really consistent in networking, particularly amongst service providers, is the networks get larger and larger and larger, and the expectations of downtime, you expect less and less and less downtime. But the team sizes are still tiny. You get these tiny teams running these giant complex networks. And so something that helps you do this analytics and maybe have a little bit more natural interaction where you don't have to remember all of your field names, all of your variables, all the different locations you have to click on. I mean, obviously you have to remember a lot of that stuff in your job, but the less of that you have to remember, the better. And just like the speed of jumping into a query and iterating on it is super interesting to help small teams sort of accelerate what they're doing.
I agree totally, because, as I say, more and more important services. I remember when we moved like voice and TV onto the IP network in one of my previous jobs, like many years ago. Man, that was a completely different world that the networking team was stepping into, and the root cause analysis reports were not very fun to write.
Yeah, I mean, I was enterprise side, so we were slower, I think, than you folks on the like voice over IP. But I remember the scary thing was always 911 service, right?
Oh yeah, because people are used to that one. That one must work, right? So,
yeah,
absolutely.
Yeah, that's
all right.
Sure.
I mean, I just wanted to show this, and I think we're getting to the Q&A now, right?
We are indeed. So we've had a few questions come through. Chris, Nina, thanks for that. So yeah, as you correctly said, it's now time for our Q&A. If you do have any other questions, guys, definitely feel free to use the chat box and you can add in some more while we're going through these first ones. So one I think might be quite a good start off for this section is quite a general question. Excuse me, we'll just jump around a little bit there. Where's my question gone? What would you say makes Kentik's approach to AI different or unique?
Yeah, I mean, we're playing with LLMs. I think LLMs, so playing with LLMs is not unique, but playing with LLMs in the space of network observability, there's not a lot of folks doing that yet. We're on the cutting edge of applying that technology. I think many more will jump in the pool soon and play with that. But I would say that it's really about combining the breadth of data we have on the flow and now the NMS side in our scaled SaaS solution rather than something on-prem. SaaS just tends to be much better for very large scale, and then applying like new complex queries to that very large scale data set. So that's the approach that we've taken, and we'll see where that goes. But to my knowledge, there's not another tool in the network observability space where you can do these sort of in-depth queries and iteration back and forth on network data.
Nina, anything you'd add?
No.
Okay, wonderful. Well, let's move on to our next question then, which is around kind of the training of the model. So how do you ensure that the data training the Journeys AI is reliable and accurate?
Yeah, it's a tough question. If you put garbage in, you're going to get garbage out. So we did sort of seed the system with a bunch of queries from our own engineering teams. That certainly helped get us going. And then as users use, they put in their own queries, and you may have seen the thumbs up, thumbs down, which basically starts using that data for training. Now, before we actually use that data to sort of rev a new learning process and then create a new result set of weights and essentially new model to then share out via our application, we review all of those queries. So there's user input, but that is assessed by our team prior to learning and then changing the model weights.
Okay, and following on from that, this is another question that's come through. What were some of the challenges to ensure that the query builder understands natural language inputs?
Yeah, and I think some of the challenges are, in particular in Journeys, is to hit the right data source afterwards, right? So, what are the keywords that we need to learn to make sure that we hit either the metric explorer or the data explorer, or
yeah, holy moly! This was a long question. I was just reading the fuller version of it.
I think you've answered the first bit, and then it's the maybe just pasted twice. So just ignore the second one.
Yeah, no problem. I was just thinking through all of that. There's a couple of okay, so there's maybe two biggest parts of the answer are, we did try multiple models, GPT-3 and then 3.5. We tried Turbo, GPT-4. We're using the one that was most effective for us. We have trained a lot of data, and as we were doing that training, we also then would do sessions where new users would try it, and we would observe what was working and what wasn't. And after you've seen 10 users spend half an hour typing in questions, you can start to get a sense of it's failing in this type of question. So we need to do more training with this type of question. It's failing when it comes to directions. It's failing when it comes to referencing sites, which is data that the user adds to their NMS and their flow tool. And so we're like, we need not just the data that we have, but also the data that folks like label their devices as. People want to use those labels. So all of those sort of observing and figuring out what the big groups of questions that weren't working, that was a big part of it for us. As far as keywords go, I would say by and large, we have avoided using keywords. There's one specific scenario which we haven't, which we most frequently use keywords, and that's sort of determining whether the query is about NMS or about flow data. For flow data, sometimes we get that wrong, and so the model will attempt to do that automatically purely with machine learning. But if it gets it wrong, you can put in flow or traffic or one of these words, which will tell it to for sure use the flow data or not. I think that's most of that question.
Yeah, I think you covered it.
Yeah, I think so. So yeah, thank you to to whoever sent that in for a very, very thorough question. We've got a few more here that I'd like to run through, and guys, there is still about 10 minutes. If you have any more, please feel free to send them through. But one question here is, what polling intervals are supported? So Chris, Nina, do one of you want to pick that one up?
Yeah, on the NMS side, the default polling interval is 1 minute. I think that's the right place to be in 2024 for a default. But for streaming telemetry data where it's more efficient, we'll do 30 seconds for most data points. We do 2 seconds for CPU for like live data points that I showed you in the demo. And then we can go down to once per second for special use cases.
Okay, wonderful. And then another slightly shorter, simpler question. Is there an API?
So API is something that we've done, we've historically really prioritized at Kentik, but we don't yet have it for NMS. That's something, we released NMS for the very first time at the end of January. We are actively building the API, so we're coding on that right now, but we don't yet have it.
Okay, and the last one that I can see, and again, a reminder, if there are any more questions, definitely do send them through. Is this SaaS or on-prem?
Yeah, we're SaaS first. So, that we have been so for the last 10 years since the founding of the company. We accept Flow on SaaS, and this NMS is also SaaS first. We do have a handful of very large customers who require on-prem, and sometimes we can make that work if the scale is sufficient, but we're predominantly SaaS.
Okay, brilliant. Well, I'm not seeing any more questions come through, so I will pop up our thank you slide. And also, thank Chris and Nina for joining us today and providing some great insights. For everyone watching, whether live or on demand, please don't hesitate to reach out to either of them if you are interested in finding out some more information. And thank you everyone for joining and for watching. We hope this has been useful. And finally, last bit from me, don't forget to sign up and subscribe to Capacity Media. We've got a bunch of more webinars and like this coming up over the rest of the year, and some really, really interesting content on AI and network operations as well. So thanks very much for joining, guys, and hopefully we'll see everyone again very soon.